Hello everyone, my name is Ramon Romero and today we're going to present a research project about the production line for a biodegradable packaging here at Zamorano.
And my name is Rosa, and we will explain the importance of this biodegradable packaging in the food industry. We will talk about the raw materials that we select, the production processes, the mass balances, the required equipment, and how this proposal have the impact in the environment.
Yeah, so to start this, we would like to give a context on why this kind of research are really important today. So basically, globally, there is a lot of contamination coming from plastic waste. Petroleum plastics based are takes up to hundreds of years to decompose in soil, creating a lot of contamination in the environment, in oceans, rivers, soils, and in a lot of communities. So in this context, this kind of alternatives, bioplastics made from fruit and vegetables waste, are a great solution that right now the industry are taking really in count.
Yeah, you are right. The fruit and vegetables production represents a large amount of waste every year. According to our investigation in the literature review, Dilucia et al. 2020, from 40 to 50% of agro-industrial waste is discarded. Instead of discarding these materials, we can use it to produce more products following the circular economy.
Yeah. So in the research, we have couple of objectives that we wanted to resolve, right? So the first one will be it was identify our industrial residues with potential for producing bioplastic with the waste here in Zamorano. And we wanted to design the pilot scale line production here for the Zamorano Laboratory of Engineering.
Also, we want to analyze the technical and economic feasibility of implementing this in a pilot scale in the packaging in the agro-industrial sector.
Yeah. So for this, we had a couple of criteria to take in count to select the material. So we took in count a couple of options. Before doing the research here in Zamorano, we wanted to see what kind of materials will be required to create either a bioplastic or a biodegradable paper. So we thought in using potato, cassava,
Coffee pool.
coffee, and also banana peels. So after that, we did all that research, right? We wanted to focus here in Zamorano. So we selected a couple of criteria to take in count. The first one was we wanted to use our industrial waste available on the Zamorano campus. So for this, we talked with a couple of engineers in charge of production lines here in Zamorano. So at the end of the day, we selected mango peels, right? Because right now is the season of mango. So this will be depending on the season of the Zamorano production. But right now we have a lot of mango waste from the mango processing. So also we wanted to check the evidence, the scientific evidence of the feasibility of producing this bioplastics.
Also, we want to take in count the feasibility of using different residues like the pulp, the peels, the seeds of fibers, and how can we apply this to the processing in the engineering laboratory.
Yeah. So as I mentioned, for the line A, for the bioplastic, we selected mango peel, right? Because right now it's the season, and right now there's a lot of waste coming from the production of mango. And so after the research, we selected the mango peel because of its characteristics as well. Has a starch, pantene, and polyphenols that will help to create the bioplastic and will give them some stiffness as well. Pigment has a natural cohesion for all the materials, has antioxidant properties, and the difference with a regular plastic based on petroleum, this one takes up to 15 to 30 days to decompose in the soil compared to the 100 years of the petroleum-based plastic, there's a significant difference. And to create the bioplastic with mango peel, we have to use some additives such as glycerol, citric acid, and cornstarch. That will be explained in the processing of how we use these materials, right?
For the line B, the biodegradable paper, we first choose the post-consumer recycled paper. One of the reasons why is the very high availability here in the campus. Also, the properties like the cellulose percentage from 60 to 75%, and it contains fibers. Like these fibers will help us with the structural base of our paper sheets, and also because it's biodegradable from 90 to 180 days. And why we choose the eggshell powder is because this act like a filler. There is a carbonate calcium. It is a mineral that help with the stiffness and the tearing index. Plus, this have reservoir proteins. Also, this is have like zero cost because it's generated by the the food innovation plant here in Zamorano. And also, we put the additive like glycerol that this will help with the crack resistance and is easier to shape when we are making the packaging.
Yeah. So we selected the material, right? So we have to design the line of production. Like what steps do we require to create the bioplastic? So for the bioplastic, first of all, we start with 120 grams of the mango peel. We washed all and we grinded it to make the particles smaller, right? And this will help us to do all the mixture with the citric acid, glycerin, and cornstarch, right? And we watered 500 milliliters of water, either for the grinding and for the mixture. After all this mixture, we heated it. We lose a little bit of water in the steam, right? After we dry all the mixture, we have a total of 920 grams of the bioplastic. And this is because we added 500 milliliters of water in the grinding and 500 milliliters of water in the mixture. So this happens because the starch in the pectin has property that help it to capture a lot of water. So we start with 120 grams of mango peel, and we finish with 920 grams of the bioplastic, right? So taking into account all the materials, we have a process of 77% of efficiency for the line A.
And from the line B, first we have the recycled paper collect. Then we do the reception and classification to avoid any contaminant. And we proceed to the paper shredding. In this step, it's important to soak in water for a while, and this will help with disintegrate the structure and make it easier. And then we remove the water, approximately 1 liter, using the press, and then we blend it and pulp it. In the other side, in the line, we have the eggshell. We start with 0.10 kilograms, and first we wash it and dry it, and proceed to the pulverization. After we have our eggshell powder, and using the wet paper pulp, we add the eggshell powder, mix and homogenize correctly. In this step, we add 5 liters of water and plus 0.05 kilograms of glycerin. After that, we mold it and do the sheet formation, and we do again the press and remove more water. And after that, we have the drying. In this step, we have like emissions like water vapor. And finally, we have the coating and finishing for the final product, our shades. And in this summary, we have the material balances. We start with our inputs 5.75 kilograms per liter. In our outputs, we have 5.45 kilograms per liter. And this difference is because the water retained in the product, approximately like 8 to 10% in the moisture.
Yeah. All right, cool. So, as we mentioned, the line that we have to use, we also have to mention all the equipment. And for the equipment, it doesn't really have like any specific equipment like hard to get. So for the equipment for the bioplastic, basically here we use glass petri dishes. Oh, that was the mold, right? We use a stainless steel pot to heat it, and a blender and stuff. And so it doesn't have to have like a really complex equipment to create this bioplastic, which is great, right?
Yes, and in the biodegradable paper we have like specific equipment, just like decal mounts with mesh, the manual roller to extract the water, the fine sieves, and also we use different like plastic or aluminum trays and the absorbent clothes.
Yeah. So after mentioning all the process, the material, and the equipment, we have to talk about money, right? The budget. So for the capex, the initial budget that we have to create this line, we have a total of 10,508 lempiras. In dollars, that's $394. But we have to say with this budget, taking in account, we'll start the line of production from zero. But since all of this equipment is already in the laboratory, so we don't have to spend this amount of money in the capex because the laboratory already have that all this equipment, right? This the blender, all the kind of stuff that we require to create this line. There's already in the laboratory. So the capex is just this is just taking into account we wanted to create it from zero.
And for the OPEX, as my partner mentioned before, the laboratory already have the infrastructure and the equipment in place. So we only need to budget the consumable inputs, just like cornstarch, 6 kilograms, the glycerin, 3 liters, and the citric acid, 3 liters also. And all plus the basic utilities and the safety supplies, just like the electrical energy, the water, the cleaning and disinfection, and the personal protective equipment. And our total OPEX is 7,800 lempiras, and which is about $292.
Yeah, and as you can see here, we're just taking into account of production for the whole month, right? So we just for the electronic energy, we just took like a rough amount of how much will the equipment require to be working 8 hours per day for 6 days per week for the whole month, right? So yeah. So this will be our project. Thank you very much for listening us, and have a great day.